Hello. In the last video, we figured out how exactly we could create a vector normal to a given plane using two vectors within that plane. We came up with these two vectors here. Let me use a different color here. These two vectors here as vectors in our plane, and defined a vector that is perpendicular to our plane. It would also mean it was perpendicular to those two vectors. So we're taking the cross product, which regardless of the quantity that it produces in terms of a vector, it will produce also a direction, and that direction will always be perpendicular to those two vectors. And since those two vectors are not sort of collinear, that will be the normal vector to our plane, which is C. But how exactly are we supposed to evaluate this? How do we find the cross product? In this video, this might be just kind of a review to some, and but others, might not know what's going on at all. So we're just going to go through the cross product math so that in the next video we can wrap it all up with the equation of a plane. So we're trying to find C here. C, and to take the cross product of A and B, which is what will give us C. We have to do this thing with determinants. Essentially, we just have to evaluate the determinants that I'm about to write here. And I'm not going to go deep into this. This is just how you calculate the cross product given vectors. But your determinant will look something like this. We're going to have the unit vectors on top. And then we're going to have these components for each one in the middle. So I'm going to have basically the A vector in the middle and then the B vector on the bottom. And actually, I'm going to draw this a bit bigger. I should have drawn that a lot bigger, actually. So C, let's give this some space. Give this a whole screen. C is going to be this large determinant here, where our I components will be x1 minus x0 and x2 minus x0. Our j components are y1 minus y0 and y2 minus y0. And our k components are going to be z1 minus z0 and z2 minus z0. So we need to evaluate this determinants. And if you're not familiar with evaluating determinants, I'm not sure if we'll have a video up at this current time on that, but I really recommend you search for other sources of information because it's really important you know that. It's some basic, essentially matrix algebra, but it's important to know here because it will be essential to finding our normal vector and ultimately the equation of a plane. Or you could just follow along and hopefully it will make sense along the way. So to evaluate this, I'm going to bring this over here. Essentially, all we're going to be doing is multiplying the diagonals this way, this way, and this way. We're multiplying those three diagonals, so it crosses over basically the end and goes back to the beginning. And then we're going to subtract these opposite diagonals. This one, and this one. And that's just made things really messy, but that's all you do to evaluate a determinant. We're just going to be multiplying the diagonals all across, adding them up when where they are basically the rightwards down diagonals. We're going to be adding all of those together and then subtracting from all of that each of these added together. So let's set that up. So that means that we're going to take I'm going to give myself even more space. I times y1 minus y0 times z2 minus, that's getting a bit confusing, z0. All right, so that's 1. then we're adding, and I'm going to put this all in brackets. I'm just going to put this all in brackets. Then to that, we are adding, now we're starting with this one. That's going to be j times z1 minus z0 times x2 minus x0, because it crosses over, right? It goes down here and then over here. And then our last term will be k times x1 minus x0 times y2 minus y0. And those are our positive terms, right? Because we go here and here. That's our last diagonal. Now then, we are subtracting from that. And I'm going to have to clear some space after this. But we are subtracting from that all of the other diagonals. I'm going to try to keep this as small as possible, but it's difficult. We're subtracting from that all of the other diagonals. So now we're going the other way. Like that. Oops. So now we're going to subtract k times x2 minus x0 times y1 minus y0. And I know this is starting to look pretty big, but we'll get through it. Now we have plus j times, what are we looking at here? Let's make sure we go in decent order. So I'm going to start with I. Oh dear. There we go. Plus I times y2 minus y0 times z1 minus z0 plus j times z2 minus z0 times x1 minus x0. Okay, so now all we need to do is put these terms together, and for that I'm going to clear a little bit of space. So hopefully you've seen the stuff up above. We've defined our a and b. You're familiar with that, because I'm going to erase all of this now. We just basically we evaluate this and we have c. You all know what that is. So I'm going to erase this so that we have some space to actually evaluate it. There we go. We just evaluate this and we will have our normal vector c. And notice it doesn't matter the magnitude of c, because all that matters is its direction, for it to be the normal vector to our plane, and hence define it. Okay, I'm going to change colors slightly. Let's see how red works out. All right, so c. I'm going to make it red now. Let's just add these terms together. So this one, this one, this one, this one, this one, and this one. We'll just add those together. So we have, and I'm going to put the unit vectors at the very end. So we are going to have, I'll just use large brackets here, y1 minus y0 times z2 minus z0 minus y2 minus y0, oh dear, times z1 minus z0. And that is our I term. Okay, so that's our first term. Now we add the next one, and that's going to be all j's. So we're going to have z1 minus z0, that's this one down here, right? Times x2 minus x0. Then we subtract this thing down here. It's going to be z2 minus z0 times x1 minus x0. And that is our j term. I should even probably color code these. J, we'll keep, and I'm gonna make K green, and K is gonna be the next one. Oh, I should probably label all the stuff. I want this to be very clear exactly what I'm doing here, because it's just kind of basic matrix stuff, but it's really easy to get confused if you lose track for even a second. I. So that's all we're doing here. So let's do K now. K is just going to be x1 minus x0 times y2 minus y0 minus x2 minus x0 times y1 minus y0, and all of that times K. And that is C. That is our normal vector, where all of these points, you know, these x1s, x2s, x whatever, all the z's, all the y's, all of these are just the coordinates to the original 3 points that we chose to define our plane. So that's pretty cool. We took our, like, kind of former understanding of planes, where it's just 3 points that define a plane, and we use those points to transform it into a vector-based understanding of planes, where we use a normal vector to define a plane instead of those 3 points. So now we've created our unit vector, and how exactly we use this to find the equation of a plane is, I think, really unique and interesting. I forgot to color code. Okay, there we go. But to move on to the next video, I'm going to make one simplification for C. And for this, I'm going to move back to, I'm going to create a barrier here. And I don't like writing all of these variables each time. I just think it's important that you know they're there so that you understand that we can derive our vector based on only those 3 points we started with. However, in the next video, I am not going to be using all of this garbage here. All of those random, well, not random, but all of those points, I'm not going to write that down each time. So I'm just going to say that C is equal to A I plus B J plus C, different C, K. That's all I'm going to say, right? Because these are just constants. These are just the points we started with. A, B, and C are all just constants. This is our vector here, C, and we know that inside A, we really have all that stuff. Inside B, we have all that stuff. In fact, I might go ahead and color code those just to be even extra clear. That A is really just, oh, I forgot to, there we go. A is really just that pink part. The blue part is our B, and the green part is our C. But I'm just going to be calling our vector AI plus BJ plus CK. And I mean, I've been using I and K and J, but really those are the unit vectors. Hopefully this was all clear. In the next video, we are going to be using this to find the equation of a plane. So I'll see you next time.